Imagine a tiny ball of dough. It holds all the ingredients for a delicious loaf of bread. Now imagine this dough expanding outward in all directions. That's a simplified way to picture the beginning of our universe. The universe started as an incredibly hot, dense point, smaller than an atom. It was full of energy, ready to burst forth. About 13.8 billion years ago, this tiny point began to expand rapidly. We call this event the Big Bang. This expansion continues even today. The universe is like that bread dough, constantly growing larger. As it expands, the universe cools and changes, creating the cosmos we observe today. The Big Bang wasn't an explosion in the traditional sense. It wasn't something happening in a pre-existing space. Instead, it was the expansion of space itself. Imagine a balloon with dots drawn on it. As you inflate the balloon, the dots move farther apart. Similarly, the Big Bang caused space to stretch, carrying galaxies away from each other. In the first fraction of a second after the Big Bang, the universe was unimaginably hot and dense. It was a chaotic soup of elementary particles. As the universe expanded and cooled, these particles began to combine, forming the building blocks of matter. Right after the Big Bang, the universe went through a period of rapid expansion called cosmic inflation. Imagine blowing up a balloon really, really fast. That's kind of like cosmic inflation. During this brief period, the universe expanded at an extraordinary rate. This rapid expansion smoothed out the early universe like ironing wrinkles on a cosmic fabric. Cosmic inflation is a crucial concept in cosmology. It helps explain the universe's large-scale structure and why it appears so uniform in all directions. Section 4. From Cosmic Soup to Stellar Cities. A recipe for stars and galaxies. As the universe continued to expand and cool, gravity began to play a significant role. Gravity pulled together clumps of matter, like cosmic dust bunnies under a giant sofa. These clumps grew larger and denser over millions of years, eventually forming stars. Stars are like giant nuclear furnaces, fusing hydrogen into helium and releasing enormous amounts of energy. Stars didn't form in isolation. Gravity pulled them together into vast collections called galaxies. Galaxies are like stellar cities, home to billions or even trillions of stars, along with gas, dust, and other celestial objects. Section 5. Black holes. The universe's vacuum cleaners. Not everything in the universe is as bright and shiny as a star. Some objects are so dense that their gravity is inescapable, even for light itself. These cosmic vacuum cleaners are called black holes. Black holes form when massive stars collapse at the end of their lives. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. Despite their name, black holes are not empty spaces. They contain an immense amount of mass concentrated in an incredibly small volume. Their extreme gravity warps the fabric of space-time, creating some of the most bizarre and fascinating phenomena in the universe. Section 6. An ever-expanding horizon, the universe's never-ending story. The universe's story doesn't end there. In fact, it's still being written. The universe continues to expand today, driven by a mysterious force we call dark energy. This expansion means that galaxies are moving farther apart from each other. It's like baking a raisin bread. As the bread rises, the raisins spread out. The universe is a vast and awe-inspiring place, full of mysteries yet to be unraveled. As we continue to explore the cosmos, we gain a deeper understanding of our place in this grand cosmic tapestry.